Welcome to another Rocky Mountain Ham University. It's kind of a snowy day here in Denver, so I hope you all had a safe trip in here. Before we get started, just a few things to remind you of. The first is HamCon Colorado. So this year, HamCon is in Colorado, October 23rd to the 26th in Grand Junction, Colorado. So please make sure that you make your arrangements for that weekend. A couple of things that you need to get ready for is we'll open up registration here in just a few days. But we also have the forums open. So if you would like to give a presentation at HamCon, please go to the HamCon Colorado website and follow the links to actually send in an abstract so that we can get you on the program. The other thing to remind you of is that our next RMHAM University is NerdFest. So NerdFest is where we talk about all kinds of interesting topics for a few minutes. The presentations are typically 20 minutes each. But if you have a topic that you want to delve into a little bit deeper, we can always extend that time if you need more time. So please go to rmham.org and follow the RMHAM University link there to sign up to make a presentation for NerdFest. So if you look at the previous years, there's all kinds of interesting discussions about things like what does the waveform look like that comes out of your UPS, and all kinds of interesting, odd topics. So very much encourage you to do that. Last thing is, I have to remind you that RMHAM is a 501c3 public charity. We rely on your donations to support all of the repeaters and network that we have. And so donations are always welcome. rmham.org is the website to go to. With that, we'll get started with today's proceedings. So this is a follow-up on the RMHAM University that was presented last year by Jim Dixon and James Isaac on 3D printing. So if you're interested in that, again, on the website is the recording of the RMHAM University where we covered what actually happens as far as the printers, the different styles of printing, everything like that. As a result of that, we said, well, you know, Jim is the master of actually designing the things that you want to print. How would you go about actually creating the objects that you're going to print? So that is why Jim is here today to give us the rundown on all of that. So thank you very much, Jim, for fighting the snow up from or down from Fort Collins, where it's snowing really hard. And take it away.
It was all Zoom only, so I don't know how many of you attended the last one where we covered 3D printing. But today we'll go through using Autodesk Fusion. There's a lot of different CAD software programs you can use, Tinkercad, Fusion, Shaper 3D, all kinds of them available. So I just picked one that I use regularly to go through that. All the terminology is going to be the same. The basic functions are the same. It's just everything that's available with the platform might change a little bit between free versions and paid versions. So we're going to go over some of the stuff with the Autodesk Fusion 360 and how I use it for amateur radio related equipment, antennas, replacement parts, stuff like that. Why Autodesk? Reason I like the Fusion the most is because there's a seamless transition between using it for CAD and CAM. So if you use it for using stuff with the CNC mill, making aluminum parts, plastic parts, metal parts, anything, you can design for both using one single software. So it's very easy to go between the two things. Combines design, engineering, and manufacturing. Ideal for customizing and prototyping and accessible to beginners. As a beginner, you can get a hobbyist license, which is free. The difference between the hobbyist license and the paid version, the hobbyist license, you can have up to 10 active designs at a time, but you can go in and make a design inactive and start a new one if you're getting close to that 10. So if you have 2 or 3 active at once, but you can have 100 in the storage system for it. So you can, as long as you don't have more than 10 active, you can keep going, which is free. So there are some limitations to the free license. It doesn't have all of the functionality as the paid version, which is understandable, but it still has 90% of it.
So how much is the paid versions? Is there different tiers?
There's different tiers. A paid version for a small company like me for a single license is $699 annually for a single licensing. So it's a little on the expensive side for the average person, but I also design stuff and make money with it. So in the end, it's worth it for me, where the average person, $700 a year is a lot of money to pay for something you do as a hobby or for the occasional part. So I definitely encourage people to go for the hobbyist license with the Fusion. We're gonna go through, yeah.
How many users could you have on the $699 version?
One.
Okay, thank you.
That's $699 per license. Each user requires their own license. Once you get up into the enterprise tier level stuff, you can get 2 to 3 users per license, but then you're talking $5,000 to $10,000 per license for enterprise level.
Is that license tied to a particular machine or?
It's tied to, it's cloud-based, so it's tied to a login credentials. And you can only log in on one machine at a time. Like I have it installed, it's installed on my laptop, my desktop, and another laptop, but if I'm logged in on one, it won't allow me to log in on another device. Which is the downside. Everything is cloud-based anymore. One of the key features for beginners, 3D design tools, easy to use interface, creating, editing. The parametric modeling, we'll go through some stuff later on that show you can go back in a timeline to make a couple changes that affect everything after it, where if you need to change the location of a hole for a screw hole or something, you can go back in the timeline, edit it in your 2D drawing, and it'll automatically change it in the 3D rendering at the end. So it allows you to go back, make changes. Simulation tool, if you're making functional parts to where stuff's going to be assembled, you can go through and actually assemble it using the software to see if you're going to run into any issues with clearance issues, trying to get multiple parts together. If they're moving parts, you can set up hinge points where the hinge is located to see if you're going to run into any clearance issues with opening or closing different parts. Cloud collaboration, meaning if you have a friend that also uses Fusion and you're making something, you can share a file with him and both you can access the same file to where you can go through, and if you have a question on something, you can share the file with them, you can open it, look at it, and you can talk amongst each other and both make changes and edits to it to refine the design a little bit. The CAM integration, I mentioned earlier, it's seamless. You can design something using Fusion and you can use it for both 3D printing or export it to use a CNC mill, lathe, anything that exports, I want to say, almost 30 different file formats that are accepted by 99% of manufacturing equipment or computer-aided manufacturing equipment. It's very easy to jump between different methods of your end product. Where to start? Download and install Fusion 360 direct from the Autodesk website. There are other places where people say get it from GitHub and everywhere else. If you want to get the newest version and not have any issues, go direct through Autodesk. Start with their basic tutorials. They have a lot of short 3-minute videos that show basic functions, how to open it, how to install it, where different things are located, which we'll cover some of that today. But knowing that their basic functions are available on their website, and they have their own YouTube channel also that covers a lot of the basic stuff. If you forget where something is, it's easy to find. Another nice thing is it's a lot of customer support and support out there between a lot of people. Familiarize yourself with the user interface. Another thing I would recommend is learn the shortcut keys. A lot of the functions you'll use a lot have their own shortcut key, to where you just hit the button on your keyboard and it automatically opens that function. The user interface toolbar browser panel displays all the components, bodies, features. The view cube navigation, you can rotate everything 360 degrees, whether it's a flat plane for a 2D drawing or 3D integration. The timeline is located along the bottom. Different symbols indicate whether you're in a 3D extrusion or drawing for the blueprint, essentially. The canvas is what they call the main workspace. So it's, if someone says go to the canvas, it means go to your main workspace area. So once we get through the slides, I'm going to open up Fusion and we'll go through some of the basic design features just to kind of do a real life scenario if you want to design something. Where editing designs are located. Some of the basic terminology is, for the drawing portion of it, it's referred to as sketching. The 2D drawing serves as the foundation of 3D features. Constraints, that is a very important feature to learn and understand, because it's, if you're designing something for, let's say, a Raspberry Pi enclosure or a circuit board enclosure, to where your screw holes are located in a very specific location, but you want to change the overall dimensions of the box later on, having those screw holes constrained into a single point helps you, because then you can change the exterior dimensions of the box without worrying about changing the location or size diameter of the holes for the circuit board to mount to. So knowing how to constrain them to a specific location, generally in a corner, in the center of the box, are your best options. But I know a lot of people, like with the Raspberry Pis and stuff like that, a lot of people try changing the exterior features and not have stuff constrained, and they'll start pressing and pulling the outside, which moves stuff inside, and then their Raspberry Pi no longer fits inside the box when they're done designing it. So learning constraints is very important. Dimensions, I would recommend getting familiar with the metric system if you're not. It's a lot easier designing in millimeters and centimeters than it is in inches. In order to get precise measurements in inches, you're dealing with 4 and 5 decimal places past your full numeric value. So instead of trying to figure out 1.12535, you can say 9.1 millimeters or whatever it works out to be. It's a lot easier for small, precise measurements. I'll never understand why a lot more people don't use it, but definitely learn millimeters, especially if you get into 3D printing. All of the 3D printers use millimeters for dimensional accuracy. So get familiar with it. If not, learn to use a conversion calculator, which aren't always 100% accurate. They're always slightly off a little bit. But profiles, closed 2D shapes can be stretched into extruded parts, meaning if you have 4 lines, and if all 4 lines are not interconnected between each other to close the shape, it can't become a 3D part. You have to have a closed profile in order to extrude it, which you can have profiles inside profiles if you have different parts and levels and layers. So it's, if someone's referring to a profile, it is referring to a closed shape or closed sketch. The body is the extruded part. Once you design, have the 2D rendering, each body will become an individual part, similar to the picture there. The body on that would be the cylinder. You can, different components, if you have them joined together, multiple bodies joined together into one component, or you can make separate components for a multi-part print or application. The feature, a 3D operation applied to a sketch, extrude, revolve, loft. Loft refers to the tapered object where you might start at the bottom with a 5 millimeter diameter circle, and at the top you're at 7.5 millimeters, so you're it's a lofted extrusion. The sweep profile along selected path creates a 3D shape. You can draw a single line that creates a path, kind of like a tool shape, and then create a 3 by 3 millimeter square that follows that path to where it sweeps along the profile of the path for curves and everything else. One thing that confuses everyone is a fillet. Everyone asks what that is. That is when you have a radius on a corner, where it's almost, if you have a 90-degree corner, I should have put an image up of it, but if you have a 90-degree corner that's similar like that, and then you have a fillet, which is almost like a perfect weld if you have two pieces of metal welded together. Nice radius between the 90-degree angle, which creates a lot of structural rigidity and makes a stronger connection point. You always want to have interior corners, you always want to have a fillet if at all possible to allow for the rigidity and structure integrity. 90-degree corner with 3D printing is never good because you're taking layer lines and moving them two separate directions, which any type of material you have in 3D printing, layer adhesion is key. And if you're dealing with a layer adhesion that's only, most 3D printers, the standard size is a 0.4 millimeter nozzle. So you're dealing with layer lines that are 0.4 millimeters in width. Isn't a very strong connection point, and the more you can spread that out over, the stronger it's going to be. A chamfer is pretty common. It can either be a 45-degree chamfer edge, or you can do a multi-measurement chamfer where it might go 2 millimeters one direction and 5 millimeters another direction, which will change the degree of angle, but it's something that's usually generally used on exterior angles just to kind of soften the edge a little bit, make it to where it's not a sharp 90-degree curve, where a fillet might not be as necessary. Your chamfer is going to give you just as much of a softened edge with a little bit better looking in the end. The shell is whenever you make a object, doesn't matter what you do, shell feature, you can click on one face of it and click the shell feature and determine what you want the wall thickness to be, and it'll automatically remove everything from the interior besides the 2 millimeter wall thickness you want. So it's, if you have something that has multiple angles and curves and everything else to where it'd be next to impossible to make it a hollow object, you can select shell feature and make all the walls the same thickness all the way around it. Makes it.
So you've introduced a whole lot of new terminology here. Is there a glossary somewhere that sort of helps you remember all of the specific names here?
A lot of it, what is in, when you first start using Fusion or most of the 3D CAD software, they do have like the information icon next to each of the features to where you can pull up a glossary there. You can also go into the information box and it'll pull up a glossary of a lot of stuff. a lot of these. I'll also make sure you have the copy of this to where you can put it on the website if people want to refer back to this also for the presentation. There are I have links at the end of it for different places that have some good informational videos and instruction also.
Get the presentation posted here during the break.
Yeah. And there's a lot of terminology, but it's become second nature after you start doing it for a little bit. By the time you're on your second and third model, you start remembering what things are called. The hardest one for me to remember for some reason was the fillet, just because I kept thinking of it as a radius and what's a fillet. Just turn it off and back on. Okay. I'll just leave this sitting on the desk or on the table. Parametric modeling, process defining dimensions and constraints to control a model. We'll go over some of that in step by step. I think a good spot, I know Willem mentioned, we'll get this uploaded during the break. There's a total of 16 slides, so I think we'll go through the slides and we can probably do the break, and then we'll go through some live Fusion stuff after break, if that would work. Seems like it'd be a good spot to interchange between the two. Assembly terms, a lot of people should be familiar with the joint, as-built joint, and rigid group. The rigid group is a fixed point between multiple connections or components. One thing some people might be familiar with is the Kraken SDR with the templates that they have, or the stuff that's 3D printed. That center hub would be considered a rigid joint because you have 4 pieces connected to one part or one point in the middle that's a rigid joint. As-built joint would be assembly parts and stuff like that, or just a regular joint would be if you have a joint between 2 pieces that are permanently connected or screwed together for a hinge or anything else. In the image that's on there, you can see there is some, if you look in the top right corner of the square with the small circle in the center, you can see that that's the circle is constrained to where it will always be 12 millimeters from each of the sides it is tied to. If you see black lines and numbers, that's a constrained line or a constrained feature. So I could change the exterior dimensions of that box to anything I want, and that circle or bolt hole, whatever it might be, is always going to be, the center of it's going to be 12 millimeters from each side. So I could increase it to 200 millimeter by 200 millimeter, and that hole's always going to be 12 millimeters from each side like that, right in the corner. Which, rendering and simulation, the nice thing is you can simulate different materials with the Fusion and a lot of different things. You can change materials, colors, features within it. They have specific physical properties of the object for manufacturing and modeling and testing within the software. With simulation, we'll go through and automatically analyze the design for stress, thermal, and other factors. If you have high movement parts with a friction fit, it'll tell you, give you thermal imaging of what can be done. That would be covered in a advanced class of Fusion, but it is all stuff that's possible. Collaboration and management, Fusion team, cloud-based platform and collaboration on projects. Version control, Fusion 360 automatically saves and tracks versions of your design. That's another nice feature, is if you're designing something and you lose connection or your computer goes down, it automatically saves files in a recovery folder for you. Where if you open up and there was something open and it's not there, 9 out of 10 times you can go to the recovery folder and it's in there. It might be 1 or 2 steps back from what you thought you were at, but you don't lose a lot of your work, which is a good thing with cloud-based software, but also a bad thing at times. Export, converts all your designs to STL, STEP, DXF, pretty much anything you could think of. STL and DXF are big ones between the 3D printing and CNC operations. Makes it easy. I know I did of design for both. Applications and amateur radio, this is where it gets really nice if you know what you're doing, and even if you have a small printer, you can do a lot of stuff that saves you a lot of time and money. The image here is from 8 years ago. I was sitting on the radio, the start of a contest, and the yoke on my desk mic broke before I had a headset. Less than an hour, I had that designed and printed on my 3D printer. And I still use it to this day. Saved me from having to hold a microphone to work a contest from home. So it's custom enclosures, antenna mounts, PCB holders, knobs, dials, cable management. There's a lot of stuff you can do, and I do a lot of stuff that makes money. I have some stuff up here that you can look at. I mean, anything from as simple as a insulator for your end-fed wire antenna, making a winder that uses a 9-to-1 balun or whatever you want on it with a toroid for portable antennas, winders. Anything you can think of, you can make and use on your own.
I mean, so, you know, I know you're making stuff here, but to get into this, are there some places that you'd recommend for some designs that, you know, as a starting point that people may have done, or that, or do you, I mean, most of this is you're starting from scratch, but can you grab some designs and do some changes, or some places that you would look to get some existing designs so you're not reinventing the wheel?
You can go to, we covered it in the 3D printing part last March or April or whenever it was, that there's sites like thingiverse.com and things.com that you can search on there for amateur radio. There's a lot of different stuff that people have designed that are very basic stuff. A lot of the stuff that you download from online is hard to edit without using some type of software to convert it, the STL, back into a mesh file, and then importing it into something like Fusion or some type of another 3D CAD software. But it is possible, but you can go there to the different, like Thingiverse, and get design, just pull pictures of what people have done to kind of inspire you to make something on your own. I mean, some of the basic stuff is easier to do.
Does the Autodesk community have a forum or place where they might have designs?
The Autodesk itself does not have anything 3D related. Well, it's used, Autodesk Fusion and Autodesk has been around for generations. That is real big into the manufacturing software aspect, where they deal with places like General Motors and Chrysler and the Fortune 500 companies for design work. So they're not concerned with the 3D printing, which is why they allow a hobbyist license on their platform. like what's on here, there's infinite possibilities between what you can design, but definitely going online or even just doing a Google search for 3D antenna parts or amateur radio 3D printed parts will give you a lot of, even if you take someone's image, there's a lot of open source stuff to where you can get a basic design and design it real quick using software, or you can go there and download the STL and print it direct from them if you want. I mean, definitely, your first print, I would do something that is downloaded from somewhere instead of versus trying to design your own and print your own for the very first time. Just so you know what your printer can do and what it's capable of, and know that it's not something that you did screwing up the design that doesn't allow it to print. First design in Fusion, create a sketch, choose a plane that you want to sketch on. We'll cover this when we open up the Fusion here shortly. You open Fusion, create a sketch, which allows you to create the lines in the two-dimensional drawing of everything, and using the extrude tool, and then saving your design to the cloud or export it to an STL for 3D printing. Practical tips for radio enthusiasts. This image is a box that I was in the process of designing for a Raspberry Pi. That's all the different openings and everything else you can see in there. Use the parametric modeling feature for adjustable design, like the standoffs for the circuit board in this are locked into that location, so I can change the outside features, outside walls, all I want, and nothing is going to change where the circuit board itself gets mounted in there, which makes it nice because allows you to edit and add different features to the outside of the box without changing anything inside the box. Using the material library to simulate different looks comes in handy whenever you want to do multicolor printing, stuff like that, that allows you to see what the different colors look like and separate parts. Or if you have multiple parts, you can set each part in a different color, so it's easier to decipher in the software between what's tied to what part and what goes where, and to color coding your drawing and design. Testing mounts and stuff using the simulation tool allows you to test hinges and how stuff bolts together for clearance issues and stuff like that, which makes it really nice before you get done spending days making a part only to figure out that you got to change one of them because you can't assemble it once everything's put together. So it's better to find that out before you spend the time actually manufacturing the part. All stuff I wish I would have known years ago when I first started doing this. Here's some of the links that will be on there. The Autodesk Learn platform, they have all their own tutorials and documentation available right from Autodesk, which makes it nice. They have a lot of very informative videos, some as short as 3 minutes for a very basic feature or location of a feature, down to hour-long seminars on how to design specific items if you get into doing gears and stuff like that, which I'm sure some people have. I know I've done, or will be. I've started printing gears and stuff, making rotators for satellite communications and stuff like that. So it's a lot of good information on there. There's YouTube channels by the Fusion 360 experts. There's a lot of other YouTubers on there. There's 2 links on there, Tyler Beck and 3D Printer Academy tutorials. Both of them are very good channels. They have a lot of good information and a lot of detailed videos on specific features. You can get into each specific feature and spend days on one aspect of design work. It's so much. I mean, I've been at it since 2013, so going on 12 years, and I feel like I don't even know a tenth of what's out there. It's endless. Like my first 3D printer I got in 2013 was XYZ Printing, which they're not even around anymore. So it's had one of the very first publicly available 3D printers, which was very slow and very slow. I mean, printing stuff in 2000, making parts in 2013 that would take 10 hours to print, now take about 20 minutes. Just to give you a little bit of an idea on the advancement in 3D printing. Yeah. That was the end of the slideshow. I'm very basic, minimal slideshow, so we'll go through the features and everything else. I don't know if we want to.
About half an hour in, so did you want to, if there's something that you can show for about, half an hour or so
Yeah.
before we take the break, then we can do the break then.
So I don't know if you're going to cover it or not, but one of the knocks on 3D printed parts is the surface finish. I don't know if there's anything that you can tell us about getting a better surface finish with the parts.
The surface finish is very hard to figure out, but once you get it figured out, is very easy to maintain. The big thing is figuring out what your layer line and extrusion rate should be. I have a couple examples up here to where the finish on it is near perfect, and it's not perfect. You're always going to have some lines in it, but it's very easy to tell it's 3D printed. Is what the side profile for the surface finish on the sides, or you're referring to like the top surface, the very top layer if it's a flat surface.
The flat surfaces and when you look at it, you can see the lines in it. A lot of times it doesn't look like the lines are straight. That makes sense.
A lot of that would come from over extrusion of filament, along with could be as simple as a worn out nozzle would cause that also. I only use, ever since, for about the past 2 years, I only use hardened steel nozzles, even if I'm printing PLA filament when it's not needed, just because of the durability and longevity of the nozzle itself. I know a lot of the printers will use a copper nozzle, which gets worn out really quick, and I think most manufacturers recommend 100 hours of printing to replace the nozzle. With brass nozzles, I would actually cut that down to about 50 hours of printing, put a new nozzle in it, because they do get worn out. And when you're dealing with stuff that's at 0.4 millimeters or 0.2 millimeters or whatever nozzle you have, if that gets opened up to even 0.42 millimeters, is going to cause a big difference in the finish.
So where do you fix this? Is it in the design program or is it more in the slicer program?
That would be more in the slicer program. You can optimize settings. A lot of it is going to be in the manufacturer's settings, which you can access. A lot of it's accessible on the printer itself, or between the interface between the printer and the manufacturing software, their manufacturer software. I know, like Bamboo Labs, you can go into the Bamboo Labs software and adjust printer settings as far as the extrusion rates and profiles and everything. Prusa printers, you can also change stuff directly in their software, your printer settings. So that's going to be in the manufacturer software mostly. You can make minor adjustments to the profile in the slicing software, but I wouldn't use them for temporary settings is one thing. I wouldn't use that for permanent settings.
before we start?
Okay, this screen up on there now? Okay. This is the basic Fusion screen when you first open Fusion 360. A lot of things we'll go through today, and I'll show a couple things that make it nice when you're manufacturing replacement parts, or if you're doing something to kind of go through. Fusion also allows you to import images in as a canvas for overlay and stuff like that if you want to design something for a specific circuit board or radio parts or anything else. When you first, if we're designing something that we'll design just a basic box, but it'll be to encompass a mesh-tastic node for 900 megahertz mesh network. If you want to do something like that, I can go up at the top to insert a canvas. Then I have the image saved on my computer. Yeah. I think this is the right one. And whenever you first open it up, before you do anything, it'll ask you what plane you want to work on. I always recommend to work looking down from the top, where you'll want to, over here in the top right corner, it'll show you the different rotations of the planes, if you want right side, left side, bottom. A good general rule for a beginner is always work from the top, so you always familiarize yourself with what is the X plane, Y and Z plane and everything. So always try and start from the same place until you're familiar with it. Then you can work from different planes a lot easier and seamlessly. So I'll select the top, and this will bring in the image, which will be a canvas. One thing to remember, if you do this, which is nice if you have half a part, that say an antenna part broke and you have half of it, but you want to design something simple, you can bring in an image of that part to kind of trace the outline of it to get it very close to what you need, almost identical with the hole spacing. If you do that, when you import a canvas or an image, always make sure you check the box that says selectable. If you do not check that box, it will not let you select it or scale the image to the correct size, which I'll show you here in a minute. This image comes in a lot smaller than the actual size is, which is why I always put a ruler. If I take a picture of something, I'll put a ruler next to it so I have something that gives me accurate measurements that I can scale to.
Seems like a horrible user interface to not make that the default, but what can I say?
Yeah. So original intention was just to allow you to put images on the side, like if you're making a design that's going to go on the side of something, or if you have something that an image is going to be pressed into, to be able to put that image on there. So I will select that, click OK. One thing, if you're using this, one of the shortcut keys that took me forever to figure out, if you have a mouse wheel and the mouse wheel is clickable, if you press down on the mouse wheel, it'll click it, you can drag everything, the canvas side to side and up and down. Just like if you press the shift key and the mouse wheel at the same time, you can rotate the image on all of the axes. Makes it really nice and easy instead of trying to go up in the corner to move stuff around to where you want it. Now that I have the image in there, I'll select the image and then go to calibrate. Calibrate will allow you to scale the image. Now if I zoom in on the image, you can see that these are all in a metric system there. So if I put the crosshair on the 15 millimeter and then right on the 16 millimeter, or 15 centimeter, 16 centimeter, you can see that when it imported it, it is showing the 10 millimeters is 1.08 millimeters. So then if I put in that that is a 10 millimeter measurement, it blew that image up to scale to where then that gives me a scaled image on there. So whenever I draw something and put lines and holes, they're going to be the exact same size as what is in the image. And now that that image is in there, I'll start creating the sketch. That is always going to be, the top left of the toolbar is going to be your create sketch. So when I click that, it'll ask me what plane I want to create my sketch on. Knowing that I selected the top plane, I'll select the top plane again to create the sketch on. That way I'm looking directly down at that image. And then if I look at the ruler compared to the Meshtastic node, you can see that that goes from 10 centimeter to just slightly over 20 centimeters. So that's going to be roughly 102 millimeters in length. So if I select want to draw a line, everything is going to be at the top what you want to do. If you want like the line, rectangle, fit point spline, or mirror images, you can also select the drop down create menu, and that gives you a lot more options. Some of these shortcut keys that are standard between all installs of this, unless you go through and change them to custom shortcut keys, the C is always going to be a center circle. L is always going to be a line. S is a shortcut key to get you to another area where you can select the search menu for selecting options. D is a dimension, gives you dimension, which we'll go into once we start drawing some lines and stuff. Like if I go in to create I want to start creating some lines to outline this. And I would always recommend going longer on your lines because you can trim off the excess, but you want to be able to do this. So if I create a line there, and with software, you'll start creating the next line. But if you don't want to create the next line, just click the check mark and then it'll allow you to move without creating the next line. It tries creating a fixed point. Where then if I go down here at the bottom to kind of get it close to that, I can start there and then it'll draw kind of past this line. And the closer you're zoomed in, the more fine the movement is between it. It tries to snap it to a grid, but if you move in, it keeps making the grid smaller. Where I can create a line there. Or an easier way, I could have just created a rectangle around this, but we'll do it the hard way to go through stuff.
It looks to me like your image happens to align pretty nicely on that grid. Is that just a coincidence, or did you actually make sure that the image that you started with is perfectly aligned with the axes?
You can adjust it if needed. I try and take them as square as possible with the camera. Whenever you take a picture to do something like this with, you want to make sure your picture is from directly above the image as straight on as possible. Yeah, the scanner works better. Like this picture was taken from my iPhone directly above it, which skews the image slightly, but it's good enough to where it allows you to make basic boxes and stuff. It gives you a basic outline to get within a 0.5 millimeter of what you need in the end. Which if you oversize stuff for a little bit of growth and expansion, you should never make something exact size because you're going to need a little bit of wiggle room in the end. As long as your holes line up, that's pretty much all that matters, but yes, the scanner does work better.
I didn't see a rotate option when you first brought it in. Is that just something I missed?
When I first brought it in, it wasn't there, but I can go back if I go out and let me finish this sketch. Now if I select it and then if I right click On it, I can select move copy, body, components, faces, like it won't, okay, it won't let me move the sketch. I thought it did. Yeah. So it constrained it there to where it won't let me move it, but everything else you can move. But this is a good part to go back. If you look down here at the bottom of the screen, this is your timeline of features. Like if I go back, I can move that timeline back to where it's not show, it won't show the sketch now. It'll only show the image that's there. And now if I go back to, come on, select that. That, now it brings the sketch back in, which, now if I go to another key feature that is good to remember is the E is the shortcut for extrude. So if I want to extrude an object, I can select that and say, let me go up 10 millimeter on that. And now if I go back to this is the timeline that I'm on right now to where it shows that part extruded right there. But if I go back to the sketch, I can go back and edit the sketch to where it'll go back in the timeline. And now if I change anything in this sketch, like I can select that line, move that line. And now if I move that line down there, finish sketch, see how it automatically change the size of that box. So if I go back and change a feature in a sketch, the nice thing, that's the nice thing with the parametric modeling is you can change a feature and it automatically changes down the road.
I mean, you know, because I always, you know, it's snapped to the grid 90 degrees. I mean, yes, you could have done it with a rectangle, but by doing it with the lines, you've got to be careful. So when you make your box, they're what, 90 degrees? Or is it just because you've got the snap on that it come out? Because it didn't look like you were, you know, taking a lot of time when you put the lines. It was just kind of at the edge. And
Yeah, I mean, a lot of it, whenever I found dealing with stuff this small, you want to try and get it close to that perfect 90-degree angles, which isn't always going to happen, especially whenever you're tracing the outline of an object. If I go in and check the angles, a lot of it might be, the one angle might be 90.2 degrees and another one might be 88.9 degrees. If you're that 1 degree difference isn't going to be the end of the world in the end design. I always try and give myself, if I have something, say if I need something that the inside dimension needs to be 90 millimeters by 102 millimeters, I'm going to design it to where it's 103, 104 millimeters inside dimension and leave, if you're doing it for circuit boards, the extrusions that the circuit board will sit on to give you an air gap at the bottom are going to make up the difference. If you try and make it an exact fit, 9 out of 10 times, something's going to happen during the manufacturing process to where it's not going to fit in without modifying it some. So I found giving yourself a little bit of lead room. We're not dealing with engine components and stuff like that that require thousandths of a millimeter tolerances. You can get away with a millimeter tolerance versus 100th of a millimeter tolerance. I mean, obviously, if you have something that you need the tolerances, then you need to make sure everything's a perfect angle on that. But generally, for what we do with it, the tolerance is a lot more flexible.
So having screwed up this sketch, is there an undo?
Control Z. That undid it right there. Except I pressed it one too many times and, oh no, I didn't. I just got to finish the sketch. Control Z does it for everything. And I'll say if I go back again to remove the extrusion. Now if I say, let me go in and draw a circle in here to kind of show what I was doing earlier. Go back in here and now say I need to put, say, a 3mm screw hole there. And then remembering that D is dimension, which will give me my constraint, or I can go there, click that line and that line. Right now the center point is 2.5323 millimeters from the center of the circle to that right hand side. Let me move that to 5mm. It automatically moves that 5mm away from that line. I can do that one. That one's at 3.1. Let me move that 5mm there also. So now I am 5mm from there and there. But now if you look, that line moved there because I did not have that line constrained into the drawing. So now if I try and extrude that, it won't let me because that's not constrained there. And now that's not a closed design, that's an open design. So now if I was to try and extrude something here, the only thing it's going to let me extrude is that center circle because that's the only thing that is a closed part. But I can select that and draw that out there. Now that is finished, and now I can extrude that while leaving that hole there. Let me go 5mm on that. Now if you notice that hole's there. But now if I want to say I want to extrude this out further with that hole being locked in right there. Right now because that changed stuff. So I screwed that up. I should have had the box constrained. But it's all learning. Okay, that didn't have there. I'll just go back and start over and delete features. I'll go back and do this. I'll show you what Mark was talking about, using a rectangle instead of doing each line. Let me redo the sketch. So now if I want to do a sketch, this will show different things. You can do a 2-point rectangle, center point right rectangle, or a 3-point rectangle, to where it'll allow you to select 3 different points that you want the rectangle to be. A lot of times I'll just do a standard 2-point rectangle. It's easy enough to do. Or I would just start there at the bottom and then come up and figure that right there at the top. It gives me that dimension there, which if you notice here, you can really see that some of it, like because of the shift with the camera image and that, you can see down here I'm right on the line, but up there it's slightly off. So that should have been slightly bigger than what I made it, but this side kind of makes up for it because it's shifted the other direction, which is another reason you want to have the scanner is optimal, because it takes direct measurements from a fixed point versus an image. Another thing to pay attention to, if you use a camera with an image and a ruler like this, make sure your ruler is at the same level as the portion that you're going to be outlining. This, for example, if the ruler is up at the level of the circuit board, even though that's an inch off the surface, I had to lift the ruler up, because if I would have left the ruler an inch down, because of the skew difference, it would have looked like the circuit board portion would have been about a 200 or 110 to 115 millimeters versus 100 millimeters. Now if I go through and put a circle in here, dimension that from the side at 5 millimeter, even though it's not that, 5 millimeters is just a good round number to use. From the side and that side, I'll put another one down here. And both of them are moved in from there. Now with them locked to each side, if I was to extrude this portion, you'll notice each one's perfectly spaced from the side. But if I move this, extrude this side out, notice only that hole is moving with it, not this one, because they're locked to separate sides. So that would change the dimensions for the circuit board to fit on there.
So why aren't you on top of those holes? You've moved them in for a little, or I guess I would think if you're going to design something, you'd have the holes kind
Yeah,
of match your part, or is this just for kind of an example?
yeah, I just did that to give it a little bit more room for this for demonstration, because them holes are actually 2.5 millimeter on center from the edge. It puts it close to where this, nice easy number for demonstration purposes. But normally you'd want to put the holes directly over the hole that's in the image that's there. But because this hole was locked into these two dimensions between this side and this end, this hole moves with it to where this one stays in place because it's locked in from the other side. Now, whenever I make something that's that I want to remain the same, hole wise, if I wanted the circuit board to be able to be mounted in there and all the holes move with each dimension, I would have initially constrained one hole to these two corners. Then the second hole, if I would have constrained it to this outside end and the center point of this hole, it will move along with that hole. To where now if I go back cancel that, go back to edit my sketch. So now if you look, because see how they're dimensioned on different sides, if I remove that constraint, and now if I dimension that and go from there, come on, from there to there, constrain that there. Now if I move this, do that same thing to this hole, now both of the holes are moving to where it'll stay there. So if I lock them together, if those were directly above the holes, I can move that entire circuit board along with it while having all this excess over there. Or vice versa, I could do it to the other side. To where if I leave that there, now even if I move this wall, this dimension here, those holes are going to move and stay right there in that corner. But if I was to come over here and do that, the holes stay in place because they're constrained to that other corner.
So you went through this awfully fast. It's kind of like when I do Vim and somebody say, "What did you just do?" And I say, I don't know, my fingers remembered what to do, but I couldn't. Could you go over what exactly the series of keystrokes are that you went to enable the constraints?
Yeah, that's my fault for knowing the shortcuts and remembering them. Just I'll back out of that. Finish sketch, Control Z. Get back here. To do the constraints and stuff like that, I have let me move this up to where we can. Oops. See it to make. We'll make Mark happy because I'll put in the dimensions that I know these are. When I first drew the circle there, you can pretty much draw it anywhere. I know the dimensions on this circuit board. It's a 2.5 millimeter hole. So I can draw the hole anywhere I want and then constrain it after the fact. The easy way to constrain is you enter the dimensions you want it from the side. So the quick key for dimension, if I am in the sketch portion, is press D. If you look at the cursor, you can see the two lines with the arrow pop up right next to the cursor. Means you're in the dimension area. Now, if I click on the circle, it automatically selects the center point of the circle. Now, if I select this outside line, it tells me I'm 2.98 or 2.92 millimeters from the side. I know with the circuit board, it's actually 1.75 millimeters. Well, if I enter 1.75 and then hit enter, it automatically moves that circle to that distance from that outside line and is constrained. It's locked to that position. If I want to lock it into the corner, I can select the circle again. I'm still in the dimension tool. It'll be quick key D or hotkey D. Select the other line that I want to constrain it to. And then with it hidden there, if I pull off to the side and then click the mouse button again, it shows you the dimensions it is from that line. So then I can enter the 1.75 millimeters from that side. It automatically moves the line to that corner. But because of the skewing of the image in that, you can see that that's actually looks further away from the hole than it is. That's why it's always good to have backup measurements. If you're doing this, this will give you a rough estimate to give you, you can look at it and say, okay, well, I have my SMA connector there. I got to make sure I have an opening in the wall for the SMA connector. It's a good reference point for dimensioning stuff. It doesn't give you accuracy. It's just for reference to know what parts go where and what you need to allow for. So now that I know that circle's constrained there, if I want to do add another circle in for up here in the top corner, and when I'm moving in and out, it's just scrolling the mouse, and depending on where your cursor is, will change the direction on what way it zooms or it moves away from the image. So if I scroll up there, now add another circle. As soon as I press the C, it gives me a center diameter circle. So I can.
Can you do a copy and paste from the other one and put it up there?
You can, kind of. It's not copy and paste, but you can move and copy. I'll show that here in a second. So where if I do this, I enter the 2.5 millimeter circle there, we'll constrain this one and then we'll do the move and copy, and I'll show you how to do that. So make the 2.5 millimeter, go back into dimensioning, and I want to leave this the same distance from this side over here as my first constraint, which is 1.75. So it keeps it the same as the other. Enter, and now I want to constrain this to the other hole so that will stay the same dimensions later on down the road. So then if I go there, constrain that there, that ends up at whatever it ends up because of the dimensions of everything else. Don't change that unless you know the exact dimension it's supposed to be. But generally, I'm guessing that would be 29.7 millimeters or 28.7 millimeters. It's just due to accuracy and all the decimal places that we don't care about. So now I know that circle is locked there. Now to go from what Mark was saying to copy and move, if I highlight that one, let me get out of the dimensioning tool. If anytime you need to get out of a tool and just go to the cursor, escape key is the quick key. Or you can go up to the top and hit the select, and that'll change it to the standard cursor. So let me select that circle, and then if I push shift, it'll allow me to select multiple features. Now that I have both of them selected, I can right click on the mouse and do move copy. It'll pull up this other window, which is me thinking I just want to move the holes, which it wouldn't really allow me because they're constrained, so it will just leave them there and won't allow me to move them. But I can check the box to create a copy. Then if I go up to the, let me zoom out a little bit, go up to the nice arrows, which makes it nice and easy. It'll allow me to slide them over wherever I want. What's nice, if I know the dimension that goes between that side and that side, I can enter the X distance because that's moving those two circles or copying them along the X axis. So it'll allow me to do that, which I'm guessing it's going to be a negative 96 because that's the direction I'm moving. Negative 90, oh, not negative 96, so we'll do 95.5 millimeters. Oops. Why? Negative 95.5, that looks like it's really close to what I needed. Now knowing that that is there, if you look, this hole is already constrained the distance from that hole. Or that circle is constrained between there, so that's going to be locked in there. But if I want to constrain this to that side, I would select dimension, or the D, so that one, and then I would constrain it to that circle, which gives me the 95.5. So I know that is constrained there between that circle and that circle. To go one step further, just to make sure I can still constrain that between there and there, which should automatically be at 1.75 because I just copied and moved it straight across the x-axis, so that's at 1.75. And now what's nice, if I finish the sketch and extrude that up 10 millimeters, it puts all of the holes are directly above. And then if you ever, let me do this real quick. If you ever want to change the opacity of the image behind it, if you're done with it, you can go over to the canvas on the left side, which is the toolbar object window, and I can hide it there if I want. Yeah. To where I could hide that, or if you just want to change the opacity down at the bottom in the edit or right click on the image, or you can go down to the timeline window and right click on that, and if I go to edit canvas opacity, cut that back to 25% to where now it's not as prominent in there. Or if you want a solid image, move it to 100%. When I generally start just the rough outline, leave it at 50%, and then back it off as you move along just to hide it in the background a little bit more.
A solid.
Yeah, right now this is a solid piece to where now if I go through, I can extrude that side, none of those holes move. I can change the dimensions on that side. All 4 of the holes move, so no matter what, all those holes are going to remain the exact same spacing, where I can change the location of the circuit board. To where now it gives me all this other room over here if I needed to, if I'm making something, say for one of the RTCM circuit board, and you want to add other objects to a single enclosure with the RTCM, you can put the layout for the RTCM to mount on there, and then expand it to where you have room to where you can add another controller, another ESP32 controller if you're using that for something, or add room within the same structure for anything else while not changing the dimensions for the mounting capability of the original object.
Comment just briefly. When you're starting out with this stuff, I was really tempted to go crazy with dimensions and constraints and make sure that everything was locked in. But I think it's kind of important to consider which dimensions actually matter, so that you have this flexibility to change things later on. Because if you have 5 millimeters here, 28 millimeters here, 5 millimeters here, you can no longer change.
No,
Everything's locked in.
The basic, to go on that, the basic features, if you're making something for a circuit board or making something for one part, leave one primary object that you're constraining. The rest of it leave open form to the ability to change. Like this, I'm making a box for this controller. I want to be able to add different things for a display and stuff like that. So if I lock in where the controller's going or the circuit board itself, lock the mounting holes in for that.
This is a good time to take a break.
Yeah.
So let's take a break till 10 o'clock. If you need to go to the bathrooms, it's upstairs. Up the stairs is the easiest way to get to. You don't get locked out. If you go to the bathroom across the hall, make sure that you get the card from Dave so that we can get to that.
Okay. Well, the break gave an opportunity to show something else with Autodesk. While I was away from my computer, the program unexpectedly quit, meaning if my computer timed out and went to sleep. If you look, it shows document recovery as soon as I reopened it, meaning it has a saved version of the most recent file that was open. Let me select that and then open. And while it doesn't have everything, it has everything up until half of the sketch. So I lost the extrusion part and moving of 2 of the holes where we moved the holes. So while it doesn't have everything, I didn't lose everything, which with something this simple wouldn't have been that bad because it's only a rectangle with two circles. But if I was 3 hours into a project or a week into a project and lost it, that might be a little bit more concerning. So, another feature, let me get back to real quick, move these different holes here. People remember how we did that. Shift key, select multiple, right click, move, copy. No, I don't want 3. Why did 2 selected? What is going on here? Oh, that's why I wasn't in the sketch, which is why it won't let me do that, so. Go back, edit sketch. Copy. No, because I remembered what it was. I can just enter negative 95.5 millimeters and automatically move them the distance I want. Now reconstrain. Make sure everything stays in the same spot. Now we're back to roughly where we were. How do you save it? Click on the disk up here to save. Or if I want to save it as something else, you can go to save as. Generally won't let you do a save as unless you save it. When you save a project, obviously you get to name it. And it'll ask you what you want to, area you want to save it in. Default project, admin project. This one I'll just put under miscellaneous. Just so it's there, and save that under miscellaneous. Before we go, let me change the.
So is this saving it on your computer or is all this in the cloud?
Right now, saving it on the cloud. And then when I'm done with the project, I'll save it locally. You can save it locally now and work on it later. What's nice is, I mean, if you're at home working with a central drive, or if you have your own network set up where you can save it on a drive that's accessible from other devices, like I can go from working on my laptop to working on my desktop at home with the same object. Change the opacity of that back to where it was back. So now that I have everything reconstrained and back where I was, now I'm trying to remember what someone asked me during the break about a portion of it. Now if I move this out to change that dimension, change this dimension here where all 4 holes come out. Now if I want to add something, add a hole or an inset for another feature on this side, or if I just want to slightly change this to add standoffs for the circuit board to sit on top of these holes. If I want to add a new sketch on top of this feature, if I highlight the feature, I can create a new sketch. That means I'm sketching on top of that extrusion. So anything I add to it is going to be added to the top, not underneath it. So say if I wanted to add, because we know the holes on the circuit board were the 2.5 millimeters, then I want to add an offset to it to where they sit up above the solid form underneath it. I select the circle that I want, and you can either select at the top up here, offset, which will create your own offset, whatever size you want. Or if I hit the short, this will give you another way to get to a lot of the features. If you don't remember where they are, if you press S, sketch shortcuts or search. Now if it's not on the shortcuts that's up there, if I start typing offset, it automatically brings up, standard offset, offset face, or offset plane. I just want a regular offset, so I can select regular offset. Default is 1 millimeter size for your offset. Well, I noticed the 1 millimeter goes over the edge, so I don't want to do, I could do a 1 millimeter and it'll end up cutting off the edge there at the end, or I can go 0.75 millimeter, which is still slightly over because that's 1.75, so I'm actually only 0.75 millimeter from the original edge. I'll leave it at 1 millimeter and show you what it does. If you look at the offset, see how part of that feature is off of the side. I'll finish the sketch real quick, but if I select that, it only selects that portion of it because there's technically a line running through that. So it's giving you two separate closed features. Or if I select that and go to extrude that, say I'll go up 3 millimeters, it automatically cuts it off right on the edge. Or it's not going to allow it to go past that. Now if I go back and say select that and go to extrude it, but I also want to extrude that 3 millimeters. It gives me the whole thing, but then it overhangs there. If you do want to do that, there's ways you can add structural rigidity to it by adding a fillet to the underside of it. If you go to 3D print this, that's so small of an overhang that most 3D printers are going to do it without an issue. But if that was more to where, say you had a 2 millimeter overhang, 3 millimeter overhang, you can't print in free space. You can try as much as you want, but you're never going to do it. They are working on ways you can do it with UV curing and laser curing with resins and everything else to print in free space, but I don't think any of us here have the money to have anything to do with that. I'll leave that there for now. If I wanted to add a fillet to it, quick key for that is F. Shocking. Most of the quick keys are the first letter of what you want to do, with some exceptions between S being the short key search menu instead of a sketch, or the C key being a circle instead of a chamfer. But if I want to do a fillet on that, a 1 millimeter fillet's too much because that's only 0.25 millimeters of an overhang. So if I go 0.25 or 0.5 millimeter overhang, it adds a nice radius to the underside of that, which is going to add a lot of structural rigidity. When you're dealing with bigger measurements than this, but if I bump that up to a 0.5 millimeter, try and cover up as much as possible, not going to happen because that's too much. So 0.45, that would be printable by any 3D printer without any type of support material, because you're starting off gradually tapering out to that. By the time you get out to this, that's less than a line width for your 3D printer. So you're going to be able to print that very easily. I know my 3D printers, they're calibrated to where I can print a 65-degree overhang without any support structure, which most people try and average. You can get 55-degree overhang without support material. You're on the upper side of things. I go back out of the cancel that. I'm going to go back to draw the rest of the diameters around that. So I could do it multiple ways. If I select offset to do an offset on everything, again, quick key O, I can go through and select, no, offset this one won't let me do everything, but I know I'm just doing everything in 1 millimeter. Makes it quick because I can go through and select everything, press O, default is 1 millimeter. So just select it, press O, and then offset, or enter. automatically put everything at 1 millimeter. Now, if I want to extrude everything from that point to make these standoffs, like it'll allow you to select multiple features simultaneously. And you can tell by each one remaining highlighted as a feature. So each one's highlighted. These corners will show you, you can see how both sides, the overhang is not going to extrude. If I wanted them to extrude, I could go through and select them individually. But because of the box, it's going to be inserted in something. I don't want them to extrude. Extrude everything. Don't need 5, so we'll go 3 millimeters. That puts everything up to where now the circuit board is going to sit on top of that and still have the bolt holes, or the screw holes for the screws to go through to mount it. While giving me the air gap underneath, whether it's for features underneath, if it's a solder through connectors or heat sinks or anything that are mounted underneath are going to have an air gap for cooling purposes. Now if I want to add to that feature, even though I extruded them, I can go back and edit that sketch by going down to the timeline, right clicking on the feature. The sketches are going to be highlighted by a box with what looks like a pencil for your sketches. Extrusions are going to be the blue rectangle with the arrow pointed up, defining extrusion. The canvas is going to be the standard picture image of what's been used since I think 1995, whenever you depict an image that's not there. Hasn't changed much. So now I can go through, edit the image. Now anything I put on here, I'm going to say I put a rectangle on there. What's nice, if I start drawing a rectangle, you can see the dimension boxes. I know I need a, say I have 50 millimeter by 15 millimeter or 15 millimeter rectangle. I know the dimensions, so I can directly input the dimensions. It'll put it in there. So now I know, say this is going to be for a small battery power supply for the circuit board. Say it's going to be like an 18650 battery that's mounted there that I always want to be in the exact same spot from where that circuit board is mounted. You can constrain it there if you want, or just hope you don't change the dimensions that move the box. Now with that extrusion there, I can, if I select extrusion for that, I can go up to make it higher, or if I go to a negative number, it'll cut into the box below it. Or say if I go a negative 2 millimeters, that puts a nice indent for a battery. If you have a battery box, it's going to sit there, so keep it from sliding around. Now with that box not being constrained, if I go there to move that, oh, now everything is tied to that spot because I made a new drawing on top of that. So it won't let you go back. Do that. So now that I added features on top of that, it doesn't let you move stuff underneath it. Now everything is exactly where it's supposed to be. I can move features to the sides, add more room here. If I want to make that bigger, to add another display section. The key is to be able to do it efficiently and quickly is learn the hotkeys for stuff. That will be the biggest aspect to help you. Another, with the S key as a shortcut, you can add stuff into this. You can take stuff out of this. Like right now, it has the chamfer, create sketch, fillet, and extrude. If I wanted to add the offset feature up there, is a quick button. If you look here, if I start typing offset, if I press the up arrow next to it, it adds offset to that list. So quick way to make a short list of features that you use a lot instead of having to go up here, go to modify, shell, draft, whatever you use the most of. Now if I was to do this, let me create a new sketch. I actually go over here, let me hide that body, hide the canvas so that's out of the way. Hide the sketch, just to kind of start new and fresh without opening up a new thing. If I want to create a box, say I want to create a box that's constrained in to the center of all three axes. If I go to center point rectangle, it automatically pulls out from the center point where I can do a 50 millimeter by 50 millimeter box. Extrude that. 50 millimeters, now we have a perfect cube, but I want to make it a shell to where it'll only have 5 sides. If I select that and select shell, this is asking me one face selected, the inside thickness 1 millimeter. That's asking you what you want the shell thickness to be. It's just moving it inside. If I want it to move outside, I can select 1 millimeter. That'll move the 1 millimeter wall thickness to the outside dimension, leaving it a perfect 50 millimeter by 50 millimeter cube inside. If I move it to the inside, you're going to end up 48 millimeter by 49 millimeter because you're removing one of the faces. So it's not going to be a perfect cube. You can also move it both directions to where it makes it a 2 millimeter wide shell thickness, but you're moving 1 millimeter inside, 1 millimeter outside. Which, if you're making small cases to slide stuff into, say if you're making something, you're putting a piece of test equipment in and you have a nice box that it sits in and it's formed into the box, but you want a hard shell to slide over top of it for transporting. Making a shelf with a thickness of 2 millimeters is going to give you a nice hard structural surface. If you throw it in your backpack or tool bag, it's not going to get damaged on the inside of that box. It's protected by the foam or whatever it's setting into, along with the hard structure around it. Any questions?
So let's say you are trying to put a 50 by 50 part in there. To what extent does the expansion of the sides, just when it prints, when it's hot, change those dimensions? Is that something that you have to design for at this stage? Or does the subsequent steps sort of take care of that?
It's going to vary between the person and the printer. I know because I've been doing it, a beginner that's just now starting 3D printing, I would build your dimensional accuracy into your 3D design, meaning give yourself a 0.5 millimeter threshold. I mean, if you have something that the dimensions of the box that you're trying to put inside are exactly 50 millimeter by 50 millimeter, build it to 50.5 or 51 millimeter dimensions. The tolerances I've established on my printers, because they print probably 75 to 100 hours a week. So my tolerances are within 0.15 millimeter tolerance, which is extremely well, but that's because when you print a lot, you start getting stuff dialed in a lot better. The average person, I would allow 0.5 millimeter to 1 millimeter tolerance. when you're dealing with this stuff like this that allows for the tolerance difference. So I would definitely build that into this. Bolt the screw holes in that if you're dealing with stuff that's under a 5 millimeter diameter for a screw hole to go into. Say if you have a 3 millimeter screw or a 2 millimeter screw, give yourself, for a 3 millimeter, dimension the hole at 3.2 millimeter for over extrusion. It's going to create it to where it might be tight, but not so tight that you can't thread the screw into it. If it's just going to be a screw that pushes through with a nut on the other side, you might have to use a screwdriver to thread it through the hole. But it's not going to be so tight that you have to force it through and drill it bigger. You'll be able to get it through by using a screwdriver. Where if you make it exactly 3 millimeters, you're going to use a drill bit and drill the hole bigger or crack it when you're trying to force it through.
Or place your circuit board with 2.5 millimeter holes on extruded pegs. And you figure out the diameter of the peg to fit inside that hole and then extrude it as a solid, not for a screw hole.
That I would still, it's easier, you have to remember it's easier to take away a little bit than it is to add a little bit. I would still allow a slight tolerance to where, say if you have a 2.5 millimeter extrusion that you want a 2.5 millimeter hole in a circuit board to fit over, I would, because you're going the opposite direction, I wouldn't go any less than the 2.5 millimeter because it's easier to take a piece of sandpaper or an X-Acto knife and kind of shave a little bit to where it fits over it. It's easier to take away than add. So your tolerance just goes the opposite direction. Instead of making it a little bit bigger, you're making it that size, trying to make it a little bit smaller. I know if you get your tolerances good enough, you can go through, if you have a hole, you can add threads to it to where if you want to screw directly into the material. Which with PLA and PETG filaments, I wouldn't really recommend it because they're too flexible. If you start printing with ABS or ASA filament, carbon fiber impregnated filament, then you can start dealing with screwing directly into the material because it's a lot more rigid and the structural rigidities there to allow the screw to hold properly. I know I've used a lot of inserts, the brass and metal inserts that you heat press into the material if I want to screw directly into it, which those you want a tight fit, and then I just have an old solder gun that I have a bigger tip on it that I can put into the insert and press directly into the hole.
When you do that, how do you make sure that it goes in square and it doesn't sort of go crooked?
I have a makeshift, I took a drill press type attachment for a Dremel and adapted it with stuff I 3D printed for a solder iron to sit in there instead of the Dremel, which allows me to press straight. Which is nice because when you start 3D printing, you're able to learn the basics and design stuff. You can design little pieces to adapt other tools to work with stuff they weren't intended to work with, which I don't know if is good or bad.
Mashtastic design that you were working on. So if you need to make that a hole for that SMA connector to go through the side of the box. So you haven't added sides to it yet, but how would you go about making sure that that SMA connector sort of is a nice tight fit, but make sure that it still aligns up with all of the screw holes? Because it looked to me like you were playing a little loose and fast with the actual placement of the board on the sketch, But then, you know, once you get to that SMA, how are you going to make sure that that SMA is still a snug fit that you can mount the board?
Okay, let's add some sides to the box real quick, just to make it a little bit easier. Easy way to add sides if I want to do all sides the same. Offset. Now, if I'm editing the sketch, I can offset it. We'll do 1.5 millimeter sides to the outside on the offset. And now if I go to extrude, because I know the original box went up 3 millimeters, we'll say 10 millimeters there. And the sketch is finished. Now we know that everything is done there. Because of opacity levels, you can still see through everything, and knowing that the SMA connector goes right there. Then I can zoom in and see that goes right there. I don't have the exact dimensions, so otherwise I would measure. If I had the part in front of me, I could use a caliper and measure how far over the part needs to go. But because we are going to be guessing on where the SMA connector comes out, not really guessing because we have an image, so we're going to be close. But I'll need to I did that not. Okay. So now it's going to be, now if I, similar to how I added the recess portion, if I click on this upper ring, it'll allow me to add a sketch there to where I can now click on that, which means anything I draw is going to be on that upper ring, which will allow me to add slots or voids and anything I want into the top to allow for different features to come through it. The downside to stuff like this is the SMA connector's there, so I could just put a small hole in the side for the SMA connector to protrude through. But then I have to deal with the buttons that are on this side, as well as the the mini USB connector for the power supply. You got to decide which one you want to be a slot and which one you want to be a small hole, holes to allow them to go in, because you're going to have to put it in on an angle. With this needing a top, I would choose to do a slot for the SMA connector to go through, and then you can always add a small extrusion to the top when it goes on to fill in the top portion of that hole. So it's kind of like a two-part to make it a single opening. So I would start at the top here. We'll do this feature first, and then I can select just the line feature at the top, or by pressing L. And because I know this is going to be close here, and with the thickness of that, I'm going to have to allow room for the hex head of the other part of the SMA to thread into, because it's going to be recessed into that slot a little bit. And whenever you're drawing lines that are attached to a feature, you can see how whenever I move the mouse, it turns into a blue X. That means I am on that line. So if I start my point from there, it's going to be attached to that line. And now another nice feature, if I want to add this to where it kind of goes in on a taper, I can define what I want that taper to be, either by doing this to where it highlights the blue X, meaning I'm at the other side of that feature. Or say if I want this to be exactly 120 degree. Oh wait, I did that backwards. Let me escape out of that. I accidentally hit 120 millimeter for the line length, which we do not want. So if I go down to go between the line length and the degree that it's at, there's just a tab button, similar to any other program, to go between boxes. If I want that to be a 120 degree angle, now no matter what, I can't move that line from 120 degrees. I can go up to where it hits that, which tells me the line length is 1.732 millimeters. I know that's exactly 120 degrees. Now if I go to the other side, I can do the same thing, which will allow, obviously the spacing is going to be off a little bit, but that would allow, to, if I wanted a perfectly sealed box, to put a taper in there with a rubber O-ring to where whenever I screw the SMA in, it's going to hit that as long as I have the dimensions right and create a seal on the box. Where I could do the same thing on this side, to where if I do a 120 degree angle, it's not going to let me change the angle, just the length of the line. To where I can do the same thing on that side. Delete that line. We'll go through here, just put straight lines across 90 degree angles. Finish that sketch because that's going to be the only hole that's going through. Now if I go to the top and extrude that, I can go down to the bottom. And if I look on this side, you can see how I can go all the way through if I wanted, which I don't want to. I only want to go down to the bottom of this feet, or the bottom of the wall. On the right side, if you look at extent type, I can go distance, object, or all. If I go to object and say I select that bottom plane right there, it's always going to, that extrusion is always going to go to that surface. I can change the thickness of everything, change the height of the wall. That extrusion is always going to go to the bottom, no matter what I do to anything else. It's adding a constraint without adding a constraint. Where now, because that SMA connector's there, whenever I make the top for it, I'll just add an extrusion that'll come out, even though the thicknesses are off, and there probably wouldn't be because that SMA is going to come out actually above that. I think it's thicker than 5 millimeters. But now say I want to go over here, because that's a slot, but I want to add holes for the micro USB. Actually, we can change that now. Change this to where it would be more realistic because of the size of that. Let me change that down to where be more realistic. So okay there. But see how I changed the bottom thickness, and that slot went down with it. To where now whenever I make the top, I can add in a little tab that'll cover that hole up to make it a solid. I could go as far as adding, if I go here before we do the other holes, to where I could add a fillet to that, but because there is no shortcut key for, oops, S, and if I started typing fillet, if it wasn't in there, start typing in fillet, it comes up in the quick aspect. Now if I select that, one nice thing with Fusion also, some of the other soft programs do it also, it'll let me select a line through an object. It knows what I'm trying to point at. Or if I move the cursor over that, it knows I'm trying to select the other side of that, or I can, oh, that's why. Cancel that. I went down too far on the That was only 5 millimeters and I went down too far, so let me move that down. I thought I completely removed the bottom. So now if I select those two, because that's a single object, I can make that into a radius. Two edges at 2.5 millimeters. So it's actually I don't know what the distance was, but if I go 2.7, is that 2.8, 2.9, close enough to a full circle. Now with that being a half radius there, whenever I can add a radius or fillets to the top portion to add a radius to where it'll be a circle and encapsulate the SMA connector. Now if I go to this side to start creating the openings for the 3 buttons and the micro USB connection, I want them to be past the holes that go through the side and not a slot coming down. So if I select that side and then create sketch, it makes it a little bit hard with the dimension. If I had a picture of the side, I can put the picture on the side to give me the holes, or I can just do this. Just remember that I'm drawing on this one. Any drawing I make is going to be on this surface right here. So I know my SMA or my micro USB power connector is right here. So I can just do a small thing to where right there I'm at the bottom of the drawing. I know I'm going to be up from that, so I'll actually start up from there. This is where constraints help some because you can automatically move it up from the bottom using a constraint. I know the opening I need for the micro mini USB. I want to say they're 8 millimeter, 8.5. We'll do 8.5 millimeter by 2 millimeter opening. But because I know the bottom surface is 1.5 millimeters thick, so I got to be at least 1.5 millimeters up from the bottom before I can cut through to the other side. So if to use the constraint, I can use the dimension there and dimension there. Well, I guess lucky at 1.56, but I want to move that to where it sits directly on the bottom. Or actually I have to allow for the 3 millimeter standoff, so I'd need to go 4.5 millimeters from the bottom surface to allow for everything. So I can go 4.5 millimeter, and that will automatically move that opening up to the level I need it. Same with the buttons are in a parallel plane with the micro USB, just different sizes. So I can add another small box right there. We'll just call them 4.5 millimeter by 1.5 millimeter. But I need to do the same thing to make sure that is constrained at the same distance from the bottom. So if I do dimension there and then dimension off the bottom, 4.5 millimeter, it's going to be the distance from the bottom line of that opening, which is what you're going to be working off of, not the top line. So remember what line you're constraining to that distance. Or you want to try and do stuff with, let's explain, you want to try and not over constrain your parts, but you need to constrain the important aspects of it. Fine line between what is important and what isn't. Button placement is important. Hole placement to mount it is important. Everything else is not important. Features that can be moved later. We'll do.
Is there like a library of common holes and things? Like, for example, micro USB or mini USB, things like that. Sort of in the same sense for circuit layout that, there's a 18-pin DIN or a dual inline package or a TO192 that you can set. Is there sort of some standard things that you can just say, that's what I need here?
There is, if you can find them. I know it's, yeah.
So I use SolidWorks, and there are features that you can, like you can make a sketch for a commonly used item, and then save that as a reference, and then just pull that sketch in on whatever plane or whatever surface. But it is a more advanced feature, and there's a lot of gotchas with doing that as far as where your origins are and where your planes are with it.
Yeah, there's you can, if you find a part, what I do is my hard drive at home, I have a lot of parts saved on as far as normal connectors and stuff. My desktop is where I do a lot of design work. And I have so much stuff saved that it's easier to save it on my NAS at home and access it from there. That's why I say they're out there if you can find them. When you find them and you know you're going to be using it again in the future, save it somewhere locally. There are a lot of places and so much stuff changes over time. I know, well, USB connectors, for example, there's micro USB, mini USB, micro 2 USB, USB-A, USB-C, USB, whatever there is. And they've dimensions have changed, physical properties have changed. RCA connectors, depending on the manufacturer, changes the dimensions of the RCA connector. So they're out there, available if you can find them. I mean, going as far as there's some companies that make it very easy to find functions and features and dimensions. I just did the foam insert for a Starlink Gen 2 dish to fit inside a box to where I wanted the physical dimensions of the dish and mounting legs and everything. To where I went directly to Starlink and found an actual mesh file to where I was able to import the mesh file that gave me the exact dimensions of everything. So there's companies that make everything very simple, and then there's companies that don't want to give you anything. So it's
Jim, we have a request from the Zoom. Gary Shade is asking about let's say you have a pre-drawn handle that you wanted to attach to that box and then print it, I guess, as one piece. Can you draw the two separately and then join them in the final piece?
Yeah, you can, if you have a 2D drawing in Fusion, or if you have the part already in Fusion as a part, you can essentially copy and paste directly between two different files. You can also go, if you go up to the top, if you have a file, it'll allow you to import an SVG file, a DXF file, a mesh file, which an STL is a mesh file in the end. They're more complex shapes with a mesh file than a STL is a standard. I can't even remember what the acronym stands for, but it's a standard dimensional format. Yeah. You can import multiple kinds of files, and you can even go as far or copy and paste one feature from one Fusion file to another. Let me draw one more box on here. This one I am not going to constrain to dimensions, but I'm still going to make it the 4.5, 1.5. Leave that one there. That one I'm not going to constrain, just to show different finished sketch. Now if I go through and say show the different things, I will extrude this one. I'll cut this one through, which is still considered an extrude. You just extrude with a negative value. but the function is going to be cut instead of create. I'm going to go take that one and go to object. I'm going to make this inner wall the object. And click OK. Now, no matter what, that one's always going to be there. Whenever you have a drawing and you go through it, for some reason, it automatically hides your sketch. If you go to sketches, you can re-enable it to where you can see it again if your sketch disappears for some reason, which will be in the menu on the left-hand side between your sketches and canvases. Now I'm going to take this one, and this one, instead of doing anything, I'm just going to do it a certain value because I know the wall is 2 millimeters thick. I'm going to go 4 millimeters thick, thinking that's going to always be there for me, no matter what I do to the outside feature. Yeah. Now on this one that is not constrained in any way, I will do this one for all, but I'm going to go the opposite direction of all. Just to show the 3 different ways, all should always give you, no matter what happens to this inner wall, it should always be the extrusion or removal should always be there. Now say I want to make this wall thicker for some reason, and I start coming in, oh, there's 1 millimeter, there's 2, 3, that's always there, along with all of them. If I go this wall and extrude that, that's strange that happened. That shouldn't have. Because this center cutout was only 4 millimeters, so it should have only allowed it to go in 4 millimeters and stopped.
Longer by removing that plane, so it actually made that hole thicker too.
Because that was there. I only want it to go a certain distance. Wall thickness is 2 millimeter. Enter. Well, that should only give me okay, figures it's not working right whenever I want it to. But technically, you always want to extrude all or extrude to a feature. That way you're guaranteed to be there. Technically, if this is only extruded to a dimension, it's only going to allow it to go to that dimension and then automatically close off at that distance. Let's always make it, I wish it was you could set it as default to always be on to object. I always select object because I know I always want it to go to the inside of that wall. And I want it to cut. Another, say if I'm doing this and I want this to be, anytime you extrude it, default is it adds on to that body. To where now if I don't want it to join, I want to make a new body out of that extrusion. Change the operation to new body and click OK. Now that makes its own body there to where I can add it and remove it. I can select that body, move it around, makes it, if you're depending on what you're doing. Yeah. Could use it for a new part, new aspect, like if I'm, with these being buttons, if I extrude it as a new body to make the button feature that'll be recessed in there, I could extrude it once into a new body, duplicate it for the rest of the buttons because I know all the buttons are going to be the same dimensions. So where now I could take this feature and say I want to move that away so I could do something else. Anytime you want to move or copy something, right now it's only going to want to move that face of the object. If I change it to the body of that object, I can move that body directly out. I should have hit OK instead of cancel. Body, move that. Ooh. Now if I extrude that the opposite direction, profile plane, distance to object. Now I know this individual body is the exact same dimensions as that hole, which would be
Okay.
perfect for a button size. Now I can duplicate that for this hole over there also.
Okay. But you can do that because the extrusion where you created that button, you did it as a body as opposed to as a join.
Yeah.
And since it's a body, it can be separated from the rest of the part.
Yes.
Okay.
Each part that's not joined is its own body. You can go over here. I can change, like this would be considered the main body, so I could change that to main body. With this individual button that I created, I could change that to button 1, and then I can create a duplicate of that for the other one and name that button 2. You can change the name of each body part, which makes it easier when you start building more complex stuff, makes it easier when you're going through with each body. Instead of referring it to body 1, body 2, body 3, you want your main body or main feature or enclosure, and then each individual part that attaches to it, its own individual name. Now, if I wanted to, you can always join two body parts into one feature if you wanted to. That's by under the modify tab. Up here, press pull or quick button Q, fillet F. It's another place where you can learn what short keys are for different features. Anytime there's a quick feature for a function, it's going to be listed next to it. Like for quick feature for moving stuff, I can press M and then select the feature that I want to move, and it allows me to move it wherever I want. Then click OK if add a fillet to something. I can press F and then go through and select the angles that I want to apply it to. That's why those got. Hide the drawing. So then if I wanted to move and copy that, press M. I want to move the whole body, but I also want to make a copy of it. And move that over there. Now, if I want to place this item back into that hole, but line it up perfect without having to fine tune it by trying to move it. If I select that line, let me do the search and then do a line. It'll let me do that. And object bodies, I want to take this line right there at the bottom corner and I want to move it. I have to reselect to there. What is going on here? No, let me remove that. I want to take that line and align it to that line. Then click OK and it automatically moves that button there while maintaining that they're two separate body features. Where I can hide it or re-enable it. And that will always stay aligned right there. Yeah.
How you made the button and slid it back in there. So will you actually print it like that and you'll have two little pieces of plastic or a little piece of plastic in that hole? Or do you have to make a tolerance in there around it? I mean, how do you actually make that button? Because the one on the left is hanging out in space and then it's not going to be printed,
Yeah.
right? Or,
You can, it varies depending on your experience level. You can print them in place with the tolerances to where they can print in place and be there and work perfectly fine. In order to get the button itself, there's additional features that you're going to have to add to it because that itself isn't going to press the button on the circuit board because that button is actually indented some, so I'm going to have to put a little, on the back of each button, you're going to have to put a little nub on there to where it'll allow you to press the button and everything else. Yeah, it'll have to be adjusted slightly to allow it to print in, not only print in place, but to be a functional button. And that comes with experience and the preparation on setting up your printer at home. If your printer's set up properly and dialed in and all the extrusion rates are set up right, you can print everything in place with no issues at all. I definitely.
My other approach, not knowing any of that, is to go out off the edge of it and make this, draw all that stuff, and then put a line that maybe was connected to it. You know how you buy a airplane model, and you get all those pieces, and you have to cut them out of where it was extruded, and basically make something like that.
Yeah.
And then grab those pieces, hit them with the file, test fit them, and you're ready to go. Is that fair?
That's another great option. That's actually done on a lot of stuff when you have a lot of small parts. Is one of the hardest thing on a 3D printer is bed adhesion, which becomes extremely difficult when you're dealing with parts that only have a 2.5 millimeter by 2 millimeter footprint. They do not like to stick very well. So you tend to put what they call as a brim or a brim around it, which extends the bottom to where if you have a 5 millimeter brim, it adds a single layer that's 0.16 or 0.2 millimeters thick all the way around the exterior perimeter of the piece that you're printing to expand the footprint for bed adhesion. Or you can do a raft underneath it, which is multiple layers, and then the part prints on top of the raft, which can become a pain to remove. So.
What I don't understand is if you were to print that button in place, how would it actually physically print without sticking to the outside?
Magic. There's, with 3D print, it's the advancement of 3D printers, it uses both part cooling and extrusion cooling to where it has a fan blowing on the part and a fan that can blow directly on the extrusion or the nozzle itself to cool the filament directly as it's coming out. And depending on the airspeed, it allows essentially an external crust to form on the filament that'll prevent it from adhering to the layer below it as long as it is not pressed too hard against it. So then you start dealing with the flow rates and everything else to where you can allow yourself, it's like a 0.1 millimeter air gap to prevent the two layers from sticking together. To where you're dealing with the nozzle, the cooling of the filament as it's being extruded versus the part cooling and everything else. It's something that never used to be possible that's possible now.
So what happens at the top, right? Because there you now need to build a cross, and it needs to adhere at the edges or but not when it's directly over the button, right?
Correct. That is referred to as bridging a gap in 3D printing. Again, it comes down to the setup of your 3D printer itself, having everything properly calibrated. I know when it comes to bridging, 9 out of 10 3D printers have no issues whatsoever bridging a 10 millimeter gap, 15 millimeter gap because of the speeds that they're moving. Some 3D printers can go up to a 50 millimeter gap as long as there is a solid object for the filament to adhere to within at both ends. It can't go out 50 millimeters and then reverse direction without having something for the filament to adhere to. So you're gonna have to, it has to have a solid piece at both ends. Or a gap for a button wouldn't be an issue going across because it's going to continue printing on the other side of it. So you're printing in free space while you're not printing in free space because the ends are connected.
Don't have anything else to go on to here. When you were doing insert, I saw there was a couple of things at the top that I didn't recognize the term. So if you click on the insert menu at the top there, insert, not inspect.
Oh,
It was insert fastener and insert derive. What does that mean?
insert fastener is exactly what it sounds like. It is a built-in add-on for inserting all standard fasteners that you want to add in. You want to add in nuts and bolts, flathead, it'll pull up as a library of all the different nuts and bolts, metric, thread pitch, thread size. It'll automatically create it for you. Kind of like you were asking about like the USB connectors, a standardized list. Well, they don't have it for electronic components yet. They do have it for fasteners. Which will be nice if they came out with it for all the different electronical components, but it's not quite there. Yeah, you can bring in any library you want.
I don't know if Fusion can do this, but SolidWorks has libraries for electronic components, and same deal. If you can model a component that you use frequently, you can add it to your own custom libraries and pull it in much easier, like this fastener toolbox.
Mm-hmm. Yeah, that's select source. I don't have any on this. Yeah, I don't have any derived files, but it's pretty much the same. At different libraries where you want to insert different features and that, and just different manufacturing parts. I know the fasteners component. I think that was, yeah, that was one someone was asking about, to where if I wanted to insert a component into this drawing. wrong ones there. Yeah. I use this for more than 3D printed stuff. I insert that part into here. So if anything that you've created on here, you can insert the full file into it. So if you've created the part once, you don't have to do it again if you want to add it to a box. Like this is a part that I did. Let me hide that stuff so we can canvas. Like this is for a storage compartment that I made for storing hot ends for one of my printers. Which I made this box, and then this is just a divider to set inside another storage box where it keeps everything organized. Or if you see, I designed each one of the hot ends to where I could do an exact match for each one. Then you start dealing with the other stuff, like see if I can find it on here. And this one. Oh, wait a minute. I think I just seen it with. Okay, any day now. And if you haven't noticed, 3D modeling is a very RAM hungry operation. Yeah. So I don't recommend having one more than 3D modeling file opened at a time, where I currently have 3. Tends to go slower. Inserting objects that were from other things. This is one that I did recently for the Starlink that I was able to, if you look there, these are the mesh files for the Starlink that I was able to find online directly from Starlink, to where it gives me each of the parts with the mesh file, to where I just essentially created a solid block and then selected the box and used this as a tool to cut away from the solid block, and then divided the block into separate pieces to where now that's like that, and then divided the block on a profile plane to where now everything is. Let me move this piece up, fits perfectly inside there to where now you can have 2 separate pieces, use a CNC to cut it out, and you know the dimensional accuracy is there because it was direct from the manufacturer on the sizes and dimensions and angles and everything. Yeah. This also shows the differences between a mesh file and an STL file or CAD. Whenever something's converted to a mesh file, which gives you dimensional accuracy, each one of these individual triangles is a plane, to where it doesn't create a curve, it creates triangles to mimic a curve. So if you import a mesh file, it imports the surface of each plane for the extrusion, which you get into tight radiuses like this, there is a lot of individual triangles, which you start dealing with mesh files. Invest in a very powerful computer because they get very power hungry and GPU hungry and CPU hungry, to where I know some in here are familiar with the different graphics cards and stuff, to where even like you get the NVIDIA, the 4090 Ti's and even the 5090s have issues keeping up with some mesh files. Just because the way they're designed and laid out, and each individual face has its own math calculations to scale everything, to keep everything consistent with measurements, and it's computing a lot more than you would think.
I'll also add with that, if you're speccing out a computer specifically for doing 3D modeling, take a look at the software's recommendations for video cards for computer specs. SolidWorks, and I'm sure Autodesk is the same way. They have video cards and computer models and processors and RAM specs that they've tested to work with that software, and specific driver versions of that hardware.
Yeah.
So if you know you're designing a PC for this stuff, go with the software's recommendations rather than just throwing high-end stuff, because there's a good chance you're going to run into driver incompatibilities, and you won't get the performance out of a high-end video card that you would have gotten with something that was designed for that software.
So I've actually, even with the Intel Intel CPUs and that, a lot of times like the older i5s and i7s, the 9600s and that work better at 3D modeling than some of the newer i9s, the 12900s. So a lot of times you can get older hardware that works better with newer software, just because of the CPU capacity and GPU capacities of the video cards and CPUs. One of the best video cards for 3D graphic, up until I haven't looked recently, some of the older ones like the old 2070s do better at basic functions than some of the newer versions like the NVIDIA 4060s and 4070s, which are still outdated, but definitely look at the specifications for manufacturers and what they recommend. Any other questions, or anyone want to see anything specific?
Well, to sort of wrap up the process, so if you were to go back to, let's say, that simple, the Meshtastic that you were building, can you show the process of now exporting that and turning it into, or running it through the slicer program and actually printing it?
Okay, we will go back to this portion of it, but if you cancel. Right now, if you notice, this is two separate bodies that are extruded here. I have the main body and body 2, which is actually the sides. I want to combine them as two. If I select both bodies and go up here to modify, and then go to combine, or if I go select both bodies and press the S button, S key, and I want to combine them into one. So combine, one selected. Okay, so now I have both of them are a single body, which means it'll, whenever I export it out for print, we'll export it as a single body instead of two bodies. Easy way to export it, if you go up to File and then Export, it'll ask me what I want to do with everything. I don't care what it's titled. Well, we'll just do mesh enclosure. The file type, whenever you're exporting for 3D print, you always want, best ones to do are either going to be a OBJ or object file or STL are the most common. You can export it for other things. SketchUp files are becoming common. A lot of people use SketchUp where you can export it directly into export it from here to import it into a SketchUp program. I always export as STL. If you start getting into the CNC, then you'll start dealing with some of the other DXF files and step files and stuff like that. But export as an STL, decide where you want to export it to. I'll just there without its own folder. Hit export. Nice thing is STL files are smaller files for the most part to where they export very quickly. Now I have that exported out of there. Now if I go to the file location where it was exported to and open it from there, you can see it was exported as STL. It'll open it in the slicer software. Because I use Bamboo printers, I have them, their slicing software is pretty much as good as any of the other ones and easy to use. You can see it brought the file directly into there. Let me change the color of the filament or color of it so it's easier to see. You can see it brought it directly in here to where I can do that now. Now because of I can actually start the print from here if I wanted to. Which, that's how you export and import into a file and then change the settings. We covered all this in last March, all the settings and that for the slicer. Slice the plate. Close out of that. If you look at this, total time for this to print is 30 minutes and 9 seconds. Prepare time for the printer is 8 minutes and 27 seconds. The cost of material to print this is 35 cents. So it becomes very inexpensive to make parts and replacement parts. I could actually no, I don't want to say one changes to that. We'll do it just for the fun of it is I'll pull something up, slice it, and then start the print here. Change of filament. That's another advantage you get when you have a multi-color printer is you can select colors and everything else direct. Slice. This item will take 47 minutes and 57 seconds to print. Cost of 87 cents. So it uses a little bit more filament. It tells you exactly how much filament it uses and everything else. And send that to my printer. My very first printer to print this probably would have taken about 14 hours or more. Yeah. And now my printer started up and going through the steps of preheating and everything else.
Where in this whole process do you discover that this print is a total disaster, that there is something unprintable, or you just made a mistake in the design somewhere and it doesn't, it's not able to actually print that object?
A lot of it comes from experience. I mean, if you designing stuff and printing stuff, I would recommend, like, your first design, go through, obviously this was a pretty basic design, but you can go through after you slice it in the software, you can go through and inspect each individual layer of the print. Where with this being basic, there's a total of 30 layers, but I can go through and see each individual layer of that. What you'll notice on stuff that's becoming unprintable is you might get into a tight radius like this to where this line might stop back here and then start back up over here because the taper gets to be too close together for the 3D printer to print. That can be addressed either by a design change or changing the nozzle size to where you can go down to a 0.1 millimeter nozzle, which allows you to give really tight angles and tolerances, but takes extremely long to print.
So what are you looking for in this process? Are you looking for lines that are not continuous, or what is it that you're looking for?
Incomplete lines, not lines that don't continue. If you start dealing with stuff that has overhangs and stuff like that, the slicing software will also give you stuff it'll turn red whenever there's an extreme overhang that would require you to add supports, which you can change the degree of overhang within the software itself to where you don't want to be warned about it until you reach a 65-degree overhang, a 57-degree overhang to adjust the thresholds of the warning. Main thing you're looking for is incomplete lines, gaps in the exterior wall, stuff that can't be printed. This is not a good print to show that on because it's so basic and there's nothing to it. It's just a flat piece of plastic. But this would be a key point if you have stuff that has tight internal angles. Checking stuff there to make sure it's complete and you have enough wall thickness to allow for it.
Enough wall thickness, is it like 5 passes?
Depends on what you have it set at. This, because I want it to be a rigid object, I have increased, this is increased to, 6 walls, or 5 internal, 1 external wall, or the outer wall shell. Depending on what you have, a lot of stuff I print will only have 2 walls because most of the rigidity comes from the internal structure.
Good thing to point out the difference between when you're in design, when you're in Fusion 360, you're only designing the outer edge of the object, and then
with the design portion of it, you're designing what you want the exterior to look like. The slicing portion of it is what you want the internal structure to be like. The design portion you're dealing with where you want a fillet or a chamfer to add to the structure rigidity, that's not the overall structure rigidity. You also have to deal with the infill and the type of infill you're using. Common type of infill, a lot of people use the cubic infill, which is just basic straight lines. Depending on the bigger parts, I found that the gyroid infill has a lot more rigidity to it because it adds more than a single dimension or a 2-dimension rigidity. It's more of a 3-dimensional structure to add more side to side, corner to corner, front to back rigidity to it. But that's if you're dealing with stuff that's only 30 layers of filament thick, which when you're dealing, that's only going to be 5 millimeters thickness. that type of infill isn't as crucial as if you're dealing with a large objects that's 150 millimeters by 200 millimeters, or 10 inch by 12 inch.
Right. But yeah, just to point out that when you're in Fusion 360, you're not worried about the number of wall passes you're doing. You're not worried about the infill type. That's all done at a later step in the slicer.
That it's all done at a later step, but I will add, keep in mind your dimensions whenever you are for the type of printer and nozzle diameter you're using. Because you know your line thickness is going to be 0.2 millimeters. So you know you print 3D print stuff at 0.2 millimeter layer thickness. You're not going to want to make something that's exactly 3 millimeters thick, because that means you're going to have something that it's only going to try and extrude half of a layer. So you want to do a 2.8 millimeter thickness or a 3.2 millimeter thickness to break that up into, or not, 2 millimeters. It doesn't work. You could do a 3 millimeter thickness, but you're dealing with a 0.4 millimeter line width. So you're not going to want to do a wall thickness that's, say, exactly 3 millimeters wide, because then it's only doing half of a line width, because you can't, 0.4 millimeter doesn't go into 3 millimeters perfect. Or, I'm sorry, I said that wrong. But you, evenly. Yeah. The math doesn't math.
I see you have a few pieces there. Did you want to describe how all of the secrets to making those?
Yeah. Another thing to keep in mind when you're designing is this piece is designed for a 9-to-1 ununded mount to a 140 core toroid. Mounts in the center. It's recessed in and zip tied into where it doesn't move, to where you can use it as a portable mobile antenna for field day or any field operation for HF. The SO239 is mounted in the opposite direction. This is what I was talking about earlier, where you have a perfect 90-degree angle. Well, when this is printed, it is printed laying flat like this. So my layer lines are horizontal to that plane. You start building up on this. If I didn't have any support structure underneath it, that would break off really easy, especially when you hang a coax to it 30 feet in the air. So not only did I didn't have much room to add a fillet or anything to the top. Well, there is one there. It's only 0.5 millimeter, which isn't much, but it's something. But I also added the side pieces underneath, which add a lot of support to it, to where you can pull down on that and it's not breaking off of there. To where this can hang up in the air, which you have to take all that into consideration when designing it to allow yourself the structure that you want. Which will, then I designed, this one is pretty much the same thing, but I made it to where everything just mounts flat on a single plane, where you don't have to worry about any of the fillets or anything. It still uses the 140 core toroid. To make it the SO239, the only difference is with this, you should have a elbow off of your SO239 to your coax. But you don't have to add anything to the structure to print this. The difference between the two is this takes about an hour and a half to print, and this takes about 40 minutes to print. So you have a trade-off between simplicity and time, or function, and not needing any additional parts to attach your coax. It's a matter of preference on what you want.
Jim, related to the one you held up there that had text on it, colored text?
They both do.
There was a question from Gary Shade asking any suggestions on how to do that.
A 3D printer with an automatic material selection device.
For the colors, what if you just wanted to do it all one color?
Oh, and even to have it recessed in, you can do it if you only have a single filament device. You can change it during the printing process. The easy way is you can go directly into the G code. It's whenever you're printing, it uses a G code to the printer. That's how the printer knows where to move to. You can go in, add lines of code into the G code if you're capable to. I say capable because not everyone has enough experience to alter a G code without creating more hassle. You can add a pause in it there to change the filament, or you can also go in, if you're quick enough, use a pair of side cutters, cut the filament as it's going into the extruder head, and feed the different color filament in as it's going in. I've done it both ways. Neither are fun, but it is possible. Yeah, I mean, you can add whenever you're designing it in the software in Fusion and any AutoCAD, Shaper 3D, Fusion, Tinkercad, all of that, you can add text to anything you want, and then just change the color as you're printing it wherever you want it.
Same lines as you were saying, you have to be careful with the direction of printing. So this little clamp thing that you made for us, what's the trick to make these legs such that they don't just break off?
Filament type, this is printed with PETG filament, which has some flexibility to it. And these are a better option. If you look at the bottom, there is a nice fillet at the bottom along with the sides to allow for rigidity in it, for structure for the layer adhesion. Some of the better filament for, if you want layer adhesion, depends on filament type also. PLA is the most common that people use because it's cheap, easy to use. If you start printing parts to use for functionality that you know are going to be outside, learn and practice with PETG filament. It's harder to use than PLA, but it has UV protection, or it's UV resistant, chemical resistant, and flexibility. I mean, you can take this and move it around. It's not affecting the print at all. These legs will bend in. I mean, obviously, if you pull on it really hard, it's going to break off just because of the layer adhesion, but there's enough there to where it's not going to break off very easily unless you force it to. But that's all done in the design process with the fillets and chamfers.
Questions from the audience?
There we go, back to printing. And that's the first layer going slow for bed adhesion.
Give us a quick recap of this discussion that you had a year ago about the different printers and sort of if somebody's just starting with 3D printing from scratch, what you would recommend in terms of a printer to get that is entry level if you don't want to necessarily make a big investment, or if you think you're going to be doing this on a regular basis, what's the trade-offs in terms of cost and capabilities?
Yeah, printers today, even the past 10 months, they've changed drastically. Even recently, I know I use bamboo printers. I've used XYZ printing was one of my first printers. They're from 2013, 2014 era. You want to get, I lean more towards with the XY core printers, which is, they have XYZ print, or the XY core, and what the other one is people refer to as a bed slinger. The bed slingers are the ones where the print bed moves front and back and up and front and back, to where the XY core, your bed only moves up and down, which when you're only moving the print head allows you to print quicker and a better quality because it's less moving mass. Where you start printing a big part and you're moving the bed around, trying to get it lined, the belt's trying to get it lined up, tend to get off a little bit and you end up with more issues. So definitely one where the print head does all of the movement except for up and down. Prusa is a good printer. The Ender 3D Pro, as long as you go with the Pro version, they're better ones. They're some of the lesser expensive ones. Obviously the now I'm drawing a blank again, but what was the other? Not MakerBot. No. They're the KA6ETE. It's a lesser known one that started doing the larger format FDM printing that are decent printers and a cheaper cost. I think it's QIDI or something. I would have to look it up again. If you can afford them, even with recent thing, Bamboo Labs just changed the way their firmware is, which they're for security, because just like how I did it here, access the printer through web interface. A lot of people were trying to say that they're trying to change it to where you have to go through Bamboo software to do anything with it, which isn't true. You can, if I'm at home, I can change it to where I can only access my printer through my local network. But you can change it to run on any third-party software. They're changing their firmware because they don't want to deal with the customer service of someone calling saying, I'm using Octoprint and this slicing software with your printer and this isn't working right, what's going on? Well, we don't care because it's not our software you're using. They're just updating their firmware to reflect that and only dealing with calls that are dealing with their software. So I still recommend the Bamboo Labs the most out of anyone, even with recent issues with them, which I'm ignoring and deal with daily. I have 3 Bamboo printers. For someone, a beginner, don't worry about the size of the printer. Average size printer is going to be 150 millimeter by 150 millimeter cube, or roughly thereabouts. This is my smallest printer is 250 millimeter by 250 millimeter, or 256 by 256. My biggest printer is 875 millimeter by 1200 millimeter.
You know, when you did the one last fall, or I guess last spring, you know, you talked about, you know, some of the cheaper printers and adding things on and
Yeah.
self-leveling. So with something like like this Bamboo that you have here, for the setup and the leveling, is that just fairly easy right out of the box, or?
They're pretty
what's it
much Bamboo printers. From what I found, I have 2 X1 carbons and the A1 mini. All 3 of them have been unpacked from the box, take a couple packaging screws out, plug it in, and start printing. It did everything else on its own. They have been by far the easiest to set up and the least maintenance.
How about the difference between the enclosed ones and the open frame?
The open frame ones, you are only going to want to print with PLA and PETG filaments. Do not attempt printing ASA, ABS, any of the TPU filaments, because those types of filaments do have hazardous, obnoxious fumes that come off of them with the heated filament, which the enclosure even like the P1P series from Bamboo, while it has an enclosure, it does not have the filtration. You can add the filtration later if you want for the carbon and micro filtration and everything else, which if you know you're not going to be printing anything big and you're only going to be printing small stuff with PLA and PETG filament, get an open air printer. Don't worry about the enclosure and everything else. If you're going to want to print functional structural parts using the ASA and ABS filament, definitely get one with an enclosure. If it doesn't have the filtration, that can always be added later, but that is important. As well as whenever you're dealing with ASA and ABS filament, you need your chamber temperature to be anywhere from 60 degrees centigrade up to 100 degrees centigrade along with the bed temperature, so you need an enclosure for that.
So does this one that we're watching now have the enclosure?
Yes. This one now is the X1 carbon. With the AMS, a single AMS unit and the printer is right around $1,300. That's enclosure, filtration, hardened steel nozzle, hardened steel extruder. Yeah, multiple color selection. Like right now, this printer, these are the 5 colors that I can print from, I was able to select from. Because if you have the AMS, you can have 1 external filament roll and 4 in the AMS, to where I got 4 of them are PETG and 1 ASA.
So with these filaments that you have, what are the typical length on the reels or kind of a cost difference between the reels and the different types?
The first 4 are PETG filament, which are rough anywhere from $21 for a kilogram roll up to $30 per kilogram. The ASA filament, generally around $25 to $35 for a kilogram, depending on anything else that's associated with it. You can get the carbon fiber embedded ASA filament, wood embedded. There's all kinds of additives you can get with different filaments.
So where do you just get all your filaments like on Amazon, or is it
Yeah,
you have some
Amazon.
stuff sourced locally, or?
Amazon, if you're close to a micro center, they carry 3D filaments, but there's not very many brick and mortar stores that carry it. Micro Center, fortunately, is one, but it's not close to me.
And then you'd mentioned about, some differences and changing the nozzles and some things out. Do you source those again online, or does the Bamboo stuff at Micro Center, do they carry some of that?
The Bamboo stuff, and I think Micro Center carries some stuff in stock for Bamboo. I know they carry other stuff in stock. A lot of it I order direct from manufacturer, just so I know what I'm getting, and it's inexpensive, even direct from manufacturer. I know, like, once a year I'll get an order with Bamboo Labs to order extra hot ends and nozzles and the extruder gears and everything, to where once a year I'll spend about $150 and have everything shipped directly to my house and have all the parts I need for the year for replacements and mishaps. Which I want to say one hot end with the extruder nozzle for the X1 carbon, I want to say is only like $12, which isn't. Replacement parts are inexpensive and readily available once you have the printer in your hands.